Hello, everyone, and welcome to the webinar From Reeds to Riches, a case study of a reed-based watershed bioeconomy in China. Before I pass things off to our presenters, my name is Carla Zaberki, and I'm a project manager with the International Institute for Sustainable Development, specifically in the water program. And with me in our office in Winnipeg, Manitoba, Canada today is our main presenter, Jan Felix Kobing, a research fellow here at IISD, as well as Dr. Richard Grosshans, Senior Research Scientist at IISD, and also here is Pauline Gerard, who will be assisting me with the webinar and helping out with any technical issues. So I was very pleased when I was looking over the registration list to see that we have attendees from a variety of organizations in multiple countries and several continents. Just so you have a sense of who else is sharing this virtual experience with you, I can tell you that there are people from different government departments here, non-governmental organizations, several business or industry folks, and some academics, among others. Before we start, I'd like to tell you a bit about our presenter, Jan Felix Kobing. Jan has a diploma in environmental science with majors in environmental economy and geography. He is completing his PhD at the University of Greifswald, Germany, focusing his research on wetland use and restoration in northern China. He is currently a research fellow with us here at IISD, working with our water program to help us develop the concept of a watershed bioeconomy in the Lake Winnipeg Basin. And this webinar should run for approximately an hour. And I'd like to go over a few ground rules before we begin. I'd like to ask everyone to please keep their microphones off during the webinar. Unlike mine a moment ago, it wasn't off, it just disconnected. I'd like to ask everyone to please also hold their questions until the end. We will have a Q&A session after Jan's presentation. If you have a question, I ask that you please type it into the chat window, and I'm just going to demonstrate right now. I'm going to type, please ask questions here. You should be able to find that in your chat window. And what we'll do for Q&A is that we'll read out the questions you typed rather than have you turn on your microphone, because in our experience, not all microphones work well with the webinar audio system. So it's just easier for us to read them aloud and then answer them. And now that we've covered the guidelines, I'd actually like to give Richard Grosshans the opportunity to speak a bit about Jan and IISD's work with the bioeconomy in general.
Hello, everybody. Pauline, can you hear me okay? All right, great. Really excited to be here. We've been working in this project for quite a while now, and it's really exciting for us to see it's grown from research to a really commercial applied scale. So at IISD, our Lake Winnipeg bioeconomy program area, it really focuses on how we can obtain both environmental and economic benefits for our local economies, for larger economies, and focusing on better watershed practices. So basically, how can we manage our landscapes, such as to prevent flooding issues, drought, issues with nutrient loading, which causes the issues in our aquatic systems. So how can we better manage our watersheds, but gain both environmental and economic benefits? So in our particular project here in Canada, we have been focusing on harvesting these novel, sustainable species such as cattails, which is a large plant, emergent plant that grows in wetland and wet systems. Very similar to the Phragmites reeds that Jan is going to be talking to you about. They grow in very similar environments, and they both have this really cool characteristic where they're very good at absorbing stuff like phosphorus and nitrogen, toxins. So they've been used widely for wastewater treatment and for other things. And so what we've been doing is harvesting these plants and then using the biomass as a source for bioproducts, bioenergy, biofuels. And so we gain the environmental benefit of capturing the phosphorus that these plants are absorbing, and then also creating a product or an energy source from them. And so I met Jan in Germany last year at a conference that he hosted at his university, Reeds as a renewable resource. And we really found there's a lot of collaborated areas that we can collaborate on across the continents. And so we learned that Jan's done some really interesting stuff in China, which fits really well for IISD because we also have an office now in Beijing, China, and really starting some interesting projects there as well. And so I'm going to pass it over to Jan to now talk to you about what he's been doing in China, how a guy from Germany ended up in China, and how his research compares to what we're doing over here in Canada.
Thanks, Richard, for the nice introduction, and also Carla. That was a very good start, I think. One moment, I try to figure out. Here we go. So, yeah, I will talk today about my work in China, especially about wheat and how wheat is used in a watershed bioeconomy in China. Yeah, as Richard and Carla already said, my name is Jan Köbbing, and it's part of my PhD, this work. One moment, please. How can I make the next slide? Here you can see the content of my presentation today. So I will talk a little bit about, in general, about bioeconomy, and in particular about bioeconomy in watersheds, and then about wetlands and wheat beds in China, why they are so important in China. And then I have actually two case studies about wheat use in China, which really take place in a large scale. And yeah, at the end I will come to some conclusion. Starting with the bioeconomy in general. So normally we understand under bioeconomy a sustainable economy that uses biological and renewable resources from land as well as from the sea as an input for bioproducts. And this could be bioenergy, liquid fuels, plastic, textiles, or chemicals, or some others. So it's basically not really something new. We're already doing it since centuries, like using timber or fish. So it's just a new introduced term for yeah, a kind of sustainable economy. And the bioeconomy also includes not only the use of the plants, but also green processes in industry, and as well as the recycling of products. Yeah, and if we come to the bioeconomy in watersheds, it's mainly, as Dimple Roy, the director of the ISD Water Program, said, developing bioeconomies on a watershed basis creates synergies between natural systems and socioeconomic ones. We also could say it's a combination of water management and agriculture. For example, the use of aquatic plants for some multiple benefits, which could be, for example, income generation, greenhouse gas reduction, water retention, wastewater treatment, etc. If we now come to wetlands in China, you can see here on the top right hand a map about humidity or precipitation in China. So you can see the precipitation is really focused on the south east of the country, and as more you come north and northwest, it's really got semi-arid and arid zones. So the water is pretty unequally distributed through China, and it's not only the precipitation is also the surface water. So the main rivers are concentrated in South China, which means agriculture and farming in North China can only take place with help of irrigation. The water per capita in China is only 28% of the world average, and because of the growing population, it's expected that it will decrease in the next years. 52% of the land is arid or semi-arid, which also is the case in one of my case studies. And so we have many water scarce areas. 8% of the whole total area of China are wetlands, which is around 65 million hectares. 40% of the wetlands, which you can actually see on the other map, like on the right bottom, 40% of the wetlands are under sweat, and as we can see in the next slide, we had a decrease of 21% in the last 50 years. So the wetland area, on the one hand, decreased, but also the existing wetland area changed from natural to artificial wetlands. Artificial wetlands means they were somehow converted by man to, for example, constructed wetlands or ponds or dams or agriculture, and also includes the restoration of wetlands. Also the degradation of wetlands was recognized by the government, and they invested $20 billion since '99 in restoration efforts, which is also one aim of my project, actually. In China's wetlands, which I mentioned it before, wheat, the common wheat, also the Latin name is Phragmites australis, is very common. It dominates about 1 million hectares in China and produces about 4 million tons of biomass or harvested biomass every year. So it's really like a huge amount of biomass which is already used. And 92% of the biomass is used for paper production. There are also minor uses for construction and for roofs, and actually also for export to Europe. In Europe, we are using it for thatching of roofs. My first case study will be the Wuliangsuhai Lake area. This was part of the SUVARES project, the Sustainable Water Management and Wetland Restoration project in China, which I took part from 2010 to 2013. And it was an interdisciplinary project involving also the University of Bolzano in Italy and the University of Greifswald in Germany and the Chinese Environmental Academy for Science. We choose this area because, as you can see, it's in the north of China, and as I showed before, it's arid and semi-arid area. So water is generally scarce, and irrigation agriculture can only be done by the help of irrigation. On the left top hand, you can see the general map of China and Beijing, and the case study is this square on the top. And if you below there is the Hetao irrigation watershed. You keep the bold blue line on the bottom is the Yellow River, and the water is diverted from the Yellow River through the whole area and then finally drains into the Wuliangsuhai Lake. It's about 600,000 hectare irrigation area, and it's one of the most important agricultural production bases in Inner Mongolia. The annual precipitation is only 215 millimeter, but the evapotranspiration is 2,200 millimeter. And because the drainage water is almost exclusively the water source for the lake, it's highly polluted by drainage water, by sewage and fertilizers from field, but also from domestic pollution. You can see it on the right hand. The lake is almost half covered by weed. All this green, dark green areas is weed. And as you can see in the next slide, for example, on the top right, on the bottom right hand, on the left hand, you see that even the open water area is covered with Potamogentum pectinatus, so a kind of submerged vegetation, which even makes it difficult to access the lake. And this also causes the risk of algae blooms in the lake. The lake has a very important function as a water treatment wetland before the water drains into the Yellow River again and then downstream. Also, it's important as a flood retention area in springtime when it buffers the water peaks from the Yellow River. Yeah, here you can, on the pictures, you can see the reed, and the reed, and also the whole drainage system in the Heta irrigation system. So now to come to the reed plant and why it's so important for the lake. So you can see on the right hand how reed is used, and it belongs to High Lake. It's mainly used for paper production. On the second picture shows a truck with the baled reed plant, and on the top you can see that it's also used for producing mats, which are used for greenhouse insulation. Also, the lake is important for fishing and pasturing and grazing takes place at the shores. Only from selling the reed for paper production, they have a net operation income of 11 million yuan per year, which is about 1.8 million US. Taifa harvest, the same cattle plant as ISD is using here in Manitoba, is also harvested, but it's only of minor importance. And as I said, yeah, also the submerged vegetation is sometimes harvested and used as a fodder plant. And fish catching is important, but decreasing because of the high pollution of the lake and because it's getting more difficult to access the lake with a big weed cover. And so some of the fishers already switched to agriculture. So at the shore of the lake, they started to have ponds and breed the fish in ponds. Here are more pictures showing how the reed is used. You can see it's pressed with pretty basic, simple machines into bales and then transported 700 kilometers to the next paper mill in Ninja province. Also, some reed is used as a fodder plant, as you can see on the bottom picture. And approximately 5,500 people are hired or employed for working in the harvesting season, which is pretty important because the main harvesting is taking place in winter season, which is a dead season for agriculture. So other job labor opportunities are quite scarce. Yeah, so that's why the whole reed economy at High Lake is very important for the local livelihood. But the reed plant is not only important from the monetary perspective. As we see, or as maybe some of you know, reed is also used as water treatment plant. It can by passing reed beds can be purified by denitrification, sedimentation, or uptaking of the plant. And we are mainly concentrated on the harvesting, so the uptake of the reed plant. When you remove the reed plant from the lake, also the nutrients are removed from the lake. And this can also prevent a second pollution, which means the dead reed plants are not decomposed in the lake and using oxygen. It also can be beneficial for vegetation because it removes the biomass from the lake, enables it to have a higher biomass or productivity in the next year, and also cleans up the waterways. And as I showed already, it's important for local livelihood. In the next slide, you can have get an idea. We estimate or calculated how much nutrients are removed with the reed harvesting. So at Williamstown High, approximately 100,000 tons of reed, which is really a lot of reed are removed every year, and this also removes 40 tons of phosphate and 360 tons of nitrogen. Potentially, as a restoration, you can see from the table that it's about 16 and 8% of the whole total influx of nutrients into the lake. Potentially, as a restoration tool, you could consider to harvest in summer and increase the removed nitrogen nutrients significantly. Constraints are that the summer harvest would be much more difficult because the lake is not frozen, and it also could give some conflicts with wildlife potentially. My second case study is the second biggest reed bed in the world, the Liaohe Delta, which has a reed area of 90 to 100,000 tons, hectare, sorry. And the biggest reed area actually is the Danube Delta in Romania and Ukraine, which has about 190,000 hectares. There's again a map of China on the top right hand, and the red square, the Liaohe Delta, so it's about 700 kilometers northeast of Beijing, and it's on the mouth of the Liaohe River, which flies in the Bohai Gulf. The whole delta buffers 2.8 million cubic meter water, and it's heavily managed for high reed yields. It's really, you can say, a reed farming. The water in the river is highly polluted with drainage water, sewage water, even it has wastewater from paper mills and oil. And as I said, the reed beds are heavily managed. On the bottom right hand, you can see it's burned regularly. It's also sprayed with it's sprayed to get rid of all kind of fungi or other potential damaging animals. And the result you can see in the next slide. So you have this, the brown color indicates the reed area. You can see the Liaohe Delta in 8040 in 2006. And you can also see that it's really the reed area spread, and this is due to the heavy or the sophisticated management of the area. In 2001, in the 50s, we had 20,000 hectare of reed, and in 2006 it was about 90,000 hectare of reed. And you can see that it grow into, especially into the reed areas, but also into the sea, so expanded, and also aqua farms is well expanded in that area. So the management really focused on getting rid of all the other plants except wheat, for example, also by flooding areas artificially, and also partly by seawater irrigation, which also killed other plants. The final result is that we have a harvested yield per year of 540,000 tons of wheat in 2000. The productivity is pretty high with 40 tons per hectare. And 92% of the total area is harvested. It's also in North China, so we have pretty cold winters, which make the harvest easy, and the ground is frozen. You can see it's, again, harvested with normal technical farming equipment, like a tractor and a blade on the side, and then manually bundled. It also, of course, sequestered a lot of CO2 into the wheat, which is probably, could also be seen positive from a climate perspective. The wheat is sold to local paper mills. There are 2 paper mills, and the revenue, it's 260 million yuan per year, which is about $35 million US. And the 450,000 tons of wheat results in about 25,000 tons of pulp. They have a sophisticated system because they have the reliable yields every year. They really have a sophisticated management. You can see they even use a small train to transport the wheat to the paper mills, and they chop it into small pieces and then use it for pulp production. And as I said, the Liaohe River is highly polluted, so the wheat beds are also highly important for purification of water. It also contributes to the growth of wheat. There are some studies which say 70 to 26% higher biomass production due to the nutrients in the water. And according to some modeling, the whole wheat harvesting, which also includes the harvest of leaves, so they are collected from the ground, removes 3,700 tons of nitrogen and 390 tons of phosphorus, which is like 66 and 90% of the total influx. So yeah, I think it's pretty obvious that the wheat bed, even if it's not considered as the main function, it's very important to purify the water. So I'm already coming to an end. So we have seen wheat beds are partial heavily management in China and used in many parts of China. I only introduced 2 case studies, but I could introduce several more. They produce significant revenues by mainly producing paper, but also they are now searching for other utilization possibilities, for example, energy production, or in the big increasing real estate market to use it as a construction material for indoor construction, for example. However, often wheat cannot compete with cash crops, so still wheat beds or coast beds are drained and used for agricultural crop. This is also due to that only the economic revenues from the wheat selling are recognized mainly in China, but not the other benefits which wheat bed can provide. If we ensure market demand for wheat, we can also ensure the ecosystem services which wheat bed provide. I think it's a good example for bioeconomies and watersheds, because it really took place since several years or decades already in China. It was mainly seen from an income perspective. The people used all the resources in China where land is pretty scarce, and additional benefits like habitat for wildlife, also nutrient removal, are up to now only of minor importance, but as we see, can really remove a significant share of the pollutants. And yeah, one of the constraints I have while using all this wetlands is that wildlife and also or biodiversity or greenhouse gases are not really considered up to now. As we saw, they have a for example, in Lehigh Delta, they have a highly artificial management, so they control the water table, they burn it, and this could be an issue for breeding birds and also for the peat layers. If you drain the area, potentially greenhouse gases are emitted. So this one should be also taken into consideration if used. Yeah, so that's it. Thank you for your attention. And I also want to highlight, Carla already showed it before, we have a bioeconomy brochure at ISD, so have a look on the website. You can find it there. If you have any questions that cannot be answered now in the question and answer session, you can email me. Here's my email address and also my phone number, where you can reach me in 1 week when I'm back in Germany. And also the presentation will be available on YouTube in the next days too. If you want to see it again, you can find it there. Thank you very much. Yeah, and I showed a couple of pictures and maps, and if you want to find them and want to have more information here, all the references which I used, the pictures in the beginning from Wulang Sahai I all took by myself. Thanks again. And yeah, feel free to ask me something.
Okay, I can see we are having some questions coming in. So what we'll do is read out the questions, and then Jan can answer them. So our first question is from Dermot McCurdy, and he has several questions actually. His first one is reed bed management by burning. What is the recovery period when that happens?
So as far as I know, the recovering is done pretty fast. So they do it in spring when the wheat is still, so they have first harvesting, and then they only burn the standing culms. So only like 20-30 meters which are still on the ground, and the wheat recovers in. So it's normal regrowth. You have if you burn it in February or March maybe, you still have the green culms in April or May.
Okay, so this is Pauline here. I'm going to read out the questions and then we'll pass it back to Jan so that we're not passing microphones back and forth. So the next question is, do weeds have a finite life?
So they have a finite life at some point, but these are all natural grown weeds, so there's no cultivation as they really plant weed or seed weed. So wheat can grow by growing by seeds and also by roots. So the wheat will naturally grow into new areas and also recover or rebuild on the site.
Okay, perfect. So this next question is from Jody Rutledge, and it is, what is the recovery period after harvesting?
So the harvesting takes mainly place in December and January. I didn't explain it, but wheat is a perennial grass, so it grows every year again. And in winter times, it reallocate the nutrients into the root system. So you don't extract that many nutrients from the plant, and it still has like stored nutrients in the roots, which it can use for the next year. That's so the recovery period would be every year it would grow again. And I even heard in some areas like close to the equator that you can harvest twice a year. I know that some wheat beds, for example in UK, they have a called double wheel, so they only harvest every second year. But then you still have the old stems in the wheat beds, which you, for example, you normally don't want for thatching. So the answer would be it recovers automatically, and in 1 or 2 months after the harvest, the new wheat will start growing. So as far as the ice is melted and the spring starts, it grows. And as I also mentioned, the harvest of the wheat will also clear the wheat bed, so they have a benefit in light and also nutrient availability. We saw it here in Manitoba really clear on one of our field sites. We had a harvested and unharvested side of cattle, and the harvested side was like 1 month ahead of compared to the unharvested side.
Okay, perfect. So this is just a reminder, if anybody has questions, you can type them in the chat box, and you can also see the questions that are being asked in the chat. If you don't see the chat, then there's a kind of bubble icon, blue, on the top of your screen, and if you click on that, you should be able to see what's going on in the chat. So the next question is, can you explain the factors that affect differences in total nitrogen and phosphorus removal between the 2 case studies? So just a reminder, case study 1, it was 16% phosphorus and 8% nitrogen, and case study 2, 6% phosphorus and 90% nitrogen. So what's the difference, Jan?
Yeah, so I have to admit that my field study took place at the first case study, so I really took the samples and we also measured them. And the numbers for case study 2 I have from literature. But I know that one big factor which could contribute to the higher removal or the whole the higher removal rate is that I think there was the quantity or per area of nutrients was less in the Liao Delta compared to the Woodlands High Lake, just because the area is much bigger. So that's why they said the removal rate is also higher. Which also is a factor is that, which I consider, is that in the Liao Delta, the wheat leaves are collected by hand as a fodder plant, and normally the leaves have a higher nutrient content compared to the stems. So in Woodlands High Lake, they would just be on the ground and decompose in the lake, and this could contribute. And also in Liao Delta, they studied it by having a special model where they try to estimate the nutrient removal, and they also included the channel system, which goes through the whole wetland, not only the wheat bed, but also the channels from the wheat bed. Yeah, I hope this can explain. It also could maybe one reason could also be that it's a little bit different locations, just different climate conditions. Yeah, so any more questions?
It looks like that's all the questions we have for now in the chat. I think I'm going to pass it back to anything to add, please bring it in.
Okay, great. Thanks. Those were some really good questions and a really great presentation by Jan. It's been great having you here with us at ISD in Winnipeg for the last, it's been 6 months now, right? Yeah, 6 months. As Jan mentioned, he's going back to Germany in about a week, and we're definitely going to keep in touch with him. It's been so great to share learning between Chinese and Canadian watersheds, and you've also brought in some great knowledge from Europe, where there's also fantastic potential for watershed-based bioeconomies, and where they're also doing harvesting for, I think, energy is one of the big uses there. So we're really excited to continue developing this work with you and at ISD. I should mention that we have, as Jan mentioned, recorded this webinar, so it will be available online, hopefully within the next few days. We're also hoping to have further webinars in the future from IESD's water programs and some of our other programs. I have already chatted with Richard Grosshans, whom you heard from earlier, about doing a presentation on the Lake Winnipeg bioeconomy, and he's agreed to do so. So you can look forward to hearing about that in the near future. I'll be sending out emails and promoting it once we plan for it. So thank you so much to everyone for joining us today. And no matter what time zone you're in, I hope you have a great rest of your day. Thank you so much.